Okay.
Acer is one of the makers of them. They're all pretty much the same.
Okay. Can you talk about the specs in that machine at all?
Yeah, this machine is a dual core, Core 2 machine. Acer did something interesting in that the motherboard components are actually from their notebook line, but they stuck a desktop processor in there and a desktop SATA hard drive in it.
Okay.
Although the hard drive we just tested was also a SATA hard drive.
Okay.
And it has 2 gigs of RAM. It's 64-bit capable. It met a lot of the needs we needed for testing Vista and Longhorn, because you need the 64-bit.
Sure.
It even does virtualization. It does Hyper-V.
Cool.
So it's a pretty cool machine.
Let's go ahead and turn it on and see how it compares.
Well, first you should see that it's asleep right now, and it's only drawing 4.7, no more than 5 watts of power in sleep state.
Okay.
There's a big difference in the machines in the last 6 years in terms of desktops, in that Intel built in a lot of power support into the processors, the next generation of the processors. The desktop chipsets and the notebook chipsets have gotten better, and so they now support S3 sleep states. And an S3 sleep state really powers down the machine. It's only keeping enough power alive just to keep the memory state intact.
Okay. So where the other machine, it sat around 50 watts still of draw.
Yeah.
This one is a tenth of that, 10% of that.
Yeah, it's 10%.
Okay. Because it actually shuts everything off. Okay.
Yeah, literally everything's shut off. Because of that, it's not really listening for my keyboard to wake it up, so I actually have to come around the front panel and find the power switch. There we go. Now it's waking up.
All right, so it takes a little bit of time to stabilize. Looks like it hangs out.
Yeah, it's still doing sort of a service load right now. You'll see it'll calm down soon. There, see, it likes to, its idle state is the same as the sleep state of the earlier generation.
Right.
One of the interesting things going on is speed step technology and processors allow the operating system, like Windows, to tell the processor, hey, you're doing nothing, really go slow and use no power.
Okay.
So that's one of the main benefits of the new generation of machines, is that they can do speed step on the desktop. Something's been in notebooks for a long time,
Sure.
but now it's in CPUs,
Okay.
desktop CPUs.
All right. So we're going to do the same torture test on this one that we did?
Yeah, we're going to do the same test.
Okay.
It's slightly different. Well, the hard drive part is just about the same. I'll start up the hard drive torture test. Pick the one hard drive. I think they're actually the same size hard drive. They're both 160 gigs.
Okay.
And honestly, I don't really expect the hard drive to be any more efficient under torture than the other one. Things haven't changed that much in hard drives in terms of their technology. Just their density, but not their power utilization. But we'll see here. So I'm starting the torture test. Even in this very aggressive mode, the drive itself is roughly 10 to 15% faster than the original. And as you can see, it's really gone up.
Yeah, about 10, about 10 watts.
10
about
watts.
The same as
it's about the same as before.
Yeah.
So drive power hasn't changed.
Okay.
Performance and density have gone up, but they haven't done anything to address power
Okay.
on the desktop side. All right, so then I start torturing the CPUs. Now, because of dual core, you have to run 2 instances of the Mersine Prime generator.
Okay. So you set that up so that it runs one on each core then?
Yeah.
Okay.
So start the torture here. So with one core, it's starting to roll up.
Yep, we can see one of them winding it up already.
And I'll start the other one up. And we got the other one going. And so it's starting to climb its way up. I'll even pop up the performance measurement. Here we got the CPUs. Both CPUs are running, so we're getting 100% utilization of CPU. It's not as sensitive to heat and things like that. So it's actually performing very efficiently. And the power here is about 90. I know it'll climb up to maybe 91, 92, but it's this particular Intel Core 2 processor. It has a heat boundary. The overclock boundary is much higher than its normal running. So as a result, it's even more efficient at full speed.
Wow.
If I were to start to overclock this thing, I could probably get another 50% of performance out of it. Then it would start to behave more like the other Pentium.
All right.
And another thing to point out is this processor is about 70% faster
Okay. And you can, when you run the machine generator, you can actually see those numbers.
Yeah, I can run benchmarks, and the benchmarks it's about 70% faster. Again, because you have 2 cores instead of 1, and it's just generally a faster processor.
Right. So we went to a smaller machine. We went 70% faster with about, 2/3 of the power draw.
Yeah, it's looking like around about 30-40%.
But that's what we're seeing, I guess, is the CPU. We're getting that many more CPU cycles, but we're not heating the room significantly more as a result.
That's the other thing. We've got a 70% performance boost, and it's really not any hotter.
Okay. Now, one thing I've noticed with the WhatsUp meter is as you mentioned, we've got a USB cable, so we can actually pull some data off this. We can let it log some stuff over, some data over time. Yeah,
it's got really flexible logging options. It can you can tell it, like right now I have it set up to capture and record every second. And it'll do that for a whole hour.
Okay.
You can tell it to record every minute or 5 minutes, whatever, in case you want to go for 2 days or a week or whatever. Mm-hmm. It's very flexible that way. It's just connected through a standard USB cable. And it generates graphs, and it also lets me take that data and export to Excel. So what I've got here is from some previous runs, I've generated some graphs. You can see that the sleep states are very different. Mm-hmm. Roughly 5 watts on this test, a low of about
mid
52 watts.
Okay.
The idle state on the newer machine is about 50 watts. The older machine is around 70 watts idle. When we kick in the hard drive, we're around 66 watts. And on the run, on the older one, it's around 80 watts for the hard drive total. And finally, the peak power,
which is the big difference, yeah.
The big difference here is 93 watts of power at full torture and 139 on the older machine. Mm-hmm. It is important to allow your runs to accumulate over time. Although you notice the older box takes longer to ramp up to that high power usage.
Yeah.
Whereas the newer box jumps right to its plateau and stays there. Sort of speaks about the difference in the processor technology.
Sure.
And then return to idle is more direct on the newer box. That's what's interesting, is a steeper drop in power. It's like the machine's just like, I need to go fast, and it's instantaneous, and then it immediately drops back down to low power mode without any difficulty.
All right. So you can use some of this data now, and you can actually start to come up with some estimates of real power savings by going to these new machines.
Yeah. So I have this slide here. I made an estimate, and I pretty much said it spends 18 hours sleeping, 7 hours idle a day, and runs 1 hour at maximum power draw. So that allowed me to do a comparison. So the sleep states, it's 90% more efficient, the new machine, and sleep, and 20% more efficient at idle, and 30% more efficient at its maximum use.
Sure.
That equates, if you assume it's 8 cents per kilowatt hour, and you guys extend it over a year for any meaningful number. The old machine costs $31 in power a year, and the new machine costs $11 in power a year. It's not a TCO kind of statement to say, hey, I'm saving $20 over a year for a machine. But if you're already looking, for a hardware upgrade, and there's a lot of good reasons in a particular IT org for a hardware upgrade. We really need to do it because we need to stay in touch with the latest technology. Other orgs have the same problem.
And the other key is you were out of power. You couldn't get a bigger machine.
Well, and I couldn't get a bigger machine. But the other thing is, it cost me nothing to get additional power savings. All I had to do was measure the machines and check. And that's going to, as I extend that out over my entire set of PCs, that's going to be a sizable amount of money. And I just added that to my selection criteria. I had a whole bunch of selection criteria. I just added power, and I determined a way to actually measure that power. Now, my hope is eventually manufacturers or magazines will also add this to their benchmarking, so I don't have to do all the work. But in the meantime, this is a pretty effective way to at least get some idea on efficiency.
Okay, so you've demonstrated that you save some power by just swapping these machines out. Have you got some other plans, some other things that you're going to do to reduce power here in the Adoption Center?
Yeah, and hopefully we'll be talking about them too. We want to look at things like virtualization and seeing if moving your data center virtualization, what kind of power benefits you get, how easy is it, other things like how do we get sleep states to work on all the machines in your enterprise. That can be a challenge on some machines. It's kind of esoteric, but we're going to talk about that. and maybe even some additional ways to measure your power requirements more in real time as well.
All right. Well, we're looking forward to that. Well,
Yeah.
we're looking forward to coming back. Thanks for your time today, Grant.
Yeah, you're welcome.
All right. Thanks.
Cool.